Everyone, and welcome back. Today we have 118 Pascal's triangle. It says here that given an integer num rows, return the first num rows of Pascal's triangle. In Pascal's triangle, each number is the sum of the two numbers directly above it, as shown below. So if we look at the first example here, it does show the first row 1, second row 1, 1, next row 1, 2, 1. If you notice, 2 is the sum of the column directly above. So if this is at 0, 1, 2, 2, row 2, index, and then column 1, 0, 1, if it's 2, 1, it is a sum of the values at the previous row of index column 0 and 1. And it might be just easier just to go through an example, so why don't we do that? And once again, the num rows they mean is if num rows is 5, we have a return of an array of nested arrays of size 5. 1, 2, 3, 4, 5, where each row has as many columns as the row that it represents. Okay. So the idea is to build this from ground up, or from top down more so. And the main idea is we want to keep the left and right edges as ones. Okay? So the borders will remain as ones. Borders left and right will be ones. Okay? 1. Now also, whatever the column value is, excluding these borders, which will be defaulted to ones and kept as ones, the column will be whatever is the previous row, pre-row, and of the previous row of previous column, and previous column and the cur column. So it'll be the sum of two values in the previous row, the first column being the one that's just above it, and the next column being so this is basically the current column in the previous row, and it'll be the previous column minus 1 to the left. And I realize even this is a little unclear, so let's exclude that and go from here. All right, let's say we're given num rows of 5. We'll directly represent the first example given in the example. So num rows is 5. We can say, given our two rules, we'll say, all right, let's start from the first row. So the first row we'll initialize it to, the first row, the row we're working on, the first row, which will be at index 0. The columns will be the size of the row index plus 1, okay? And we'll initialize it as such. Then we want to iterate in the between columns, excluding the first and last. In this case, it kind of represents the first and last, so we can do no more and we'll continue to the next row. Now the row index is 1. The size of the column should be 1 plus this. So at the second row, which is at row index 1, we initialize to ones multiplied by the row index plus 1. So 2 of these. And 2 of these means that we end up with something like this. Okay? Row index 1, also our second row, is done. Now we're at row index 2, which represents our third row. Here we will initialize this columns, the third row's columns, to be 3 ones, because it's 2 plus 1. Row index is 2. 2 plus 1 is 3 ones. So let's first initialize. And now at this point, remember, we want to iterate from, if this is 0, 1, 2, if this is the indexes, we want to iterate the 1, which is excluding the first position. So we'd be doing something like range from 1 to, now this part is important, we want to stop at 1. We want to stop just before the last one. The last one is 0, 1, 2, so we want to stop before 2, which is also equal to R, so we can just do that. And then that will help us proceed further. Okay, so we're done with row index 2. Let's go to row index 3, which is also the fourth row. The fourth row at row index 3. And we initialize it to, what was it? The R plus 1. So 4 values, which is 1, 1, 1, and 1. And we iterate from, so if these are the indices, we will be iterating from 1 over here, this guy, to R, which is 3, 0, 1, 2, 3. Remember, we exclude the second value, so we would be iterating these two values. And what do we do to these two values, which we haven't done here, which we do that there too? We sum up the value from directly above. So for this one, let's do a different color. So for this one, directly above would be this, and directly above to the left would be this. So this would be summed up as such, as 2. Okay, and over here, this one directly above is a 2. Directly to the above and left is 1. Summing, that would be 3. And here, directly above, remember 0, 1, 2, we want the same indices, right? So directly above is a 1. Then to the left is a 2. Sum that up, that becomes a 3. Let's work on the last row now that we have an understanding. And we are on row index 4. This is our 5th row, our final row, row index 4. We initialize the columns to the size of the index plus 1, which is 5. So 1, 1, 1, 1, and 1. And remember, we're going through the range from 1 until R, which is 4. So 1, 2, and 3. 1, 2, and 3. This is what we're concerned with. Now let's see. Directly above 1 at 1th index is 3. 3 plus 1, that's 4. So we do a 4 here. Directly above 0, 1, 2, the 2nd index is this guy. 3 plus, to the left is 3. So this is 6. And then here, 0, 1, 2, 3. This is 3 index over here. It's a 1 directly above. To the left is a 3. This becomes a 4. And this is what we would return as an array of arrays, like so. Okay. And as you can see, this is what we get. So let's convert that to code. And the way we can do that is actually already drawn out here. So all we did was we initialized some empty array that will continue to build. And for each row index in num rows, there are, okay, and right for range of num rows. So when num rows is 5, we would go from 0, 1, 2, 3, 4, from 0 to 4. Okay, and we would initialize columns to be all ones times 1 plus whatever R is. So it would be R plus 1. And the reason we do that once again is because if we're on the 0th row, the 0th row represents the first row, which has 1 column. And so we add the 1. And then we say for column in range, skipping the first guy, which is at 0 index, so from 1 until R, which we found out was the right value to end with here. Then we say columns at this position will be the sum of rows of the previous row. So r minus 1 and the column directly above, which would be the same column index, plus rows, again the previous row, but this time the column to the left. And once we're done going through these columns, where the borders or the edges are already defaulted to 1s, we can now add rows.append these columns. And then once we're done, we can directly return rows. Let's give that a go. Okay. And there you have it. That is, once again, 118 Pascal's triangle. Thanks so much. Happy coding. See you next time.